with obviously a long time partner, Cryptonomic. So I'll just start with a brief introduction of of Cryptonomic, and then Mike and Vishal can just give a brief introduction yourself, and then I'll sort of we can just kickstart today's workshop. So all the fellows, again, I'm back after 1 hour, and I'm really excited to kickstart this journey of learning Tezos, how to build smart contracts, how to build decentralized applications, and cool and awesome stuff that we are going to build in the course of next 2 weeks. So as I was mentioning that once now that you're part of this fellowship, you will get to meet some really good people, good teams. You'll get to network with people all around the world, and you'll get to know what awesome and cool things that they are building. And meanwhile, during this entire process, you will learn a lot of things yourself, right? So without further ado, let me introduce you the team of Cryptonomic. We have got Mike and Vishak here, both of them. I will just give a small introduction, but they will give us a proper one. Both of them come with a very rich
slides about this.
Yeah, they come from very rich finance and technological backgrounds, and I've worked together with them a couple of times. It's really awesome to have them as the first team to kickstart the workshop session, right? So I'll stop now. Vishak and my Cryptonomic team, we have these 30 fellows. These 30 fellows are selected out of 3,500 plus applications that we received for Tezos India Fellowship.
Wow, you guys, it's amazing.
It was a challenging process for us, for everyone, and we are really glad that we have gotten a really diverse and amazing batch, and we look forward to seeing all of these fellows building great projects, and so looking forward to your help and support as well wherever they are stuck. Right. So I'll stop. To you, Mike, I would love you guys to take over and take the floor from me.
By the way, I'm just here to listen. This is amazing stuff. Mike's doing the talking, but lovely meeting you all.
Awesome.
Excellent. Can you guys see our beautiful logo?
Yep. Yeah.
That's great. I like to pace when I talk, so I have one of these fancy clicker things to do that with. Right, I'm Mike from Cryptonomic, as Om introduced me. We have Vishak also, who's just listening, but he's the co-founder of the startup. I'm really happy to be presenting for you guys today. This is actually the second time we're doing this with Tezos India, and I really appreciate the opportunity, Om. Thank you very much. So we're going to talk about a bunch of blockchain stuff, primarily on Tezos, because of course we're going to be building interesting smart contracts on Tezos. As a company, we are an independent firm. We are committed to these hard to pronounce words and even harder concepts. We're chain agnostic in general, but a lot of the public work that we do is on Tezos. We fundamentally want to make blockchains more popular and more useful. And to that end, we build products, we build tools to support these products. We do events like this one. We're having an event actually in a week and a half in Brooklyn, where we're based. We have a small team in Bushwick. We came back to the office recently, and we were very excited to find out that the hipster cred of the neighborhood has survived the pandemic. As Om suggested, we do have broad experience in financial systems and extensive cross-domain technical expertise as well throughout the team. We've built a lot of things for blockchains. Let me show you some of them. I like to think that we bring discipline of experience of product delivery to this platform because of our previous engagements building large-scale financial systems, for example, among other things. On the non-technical side, we participate in the community as much as we can. We do events like this, so we create educational materials, we answer questions. Just random people sometimes ping me on Twitter, and I will try to help to the extent that I can, as do all of us. So the things that we built. This is a recent release of Galleon. It's actually live now, version 1.1.24, if anyone's keeping count. I think it's our 39th release of this wallet. It has support for a bunch of interesting and popular projects on Tezos for DeFi and for NFTs, which is what this screenshot is showing. We also have a mobile wallet. This is an old screenshot. It's about a year old, actually. And we have a new version coming up. We're super excited about, and I don't want to spoil the surprise. It'll be amazing, but broadly speaking, mobile wallet. Aranex. This thing in particular is close to my heart. It's a blockchain reporting tool. It allows you to create arbitrary reports on data on the chain. So for example, here, we're looking at a screenshot of a report for contract invocations after July 22nd that have failed. So you can see transaction kind, operation type transaction, status failed, destination starts with KT1. So smart contracts on Tezos have addresses that start with KT1. That's why that's there. And we're showing the error that was recorded, the function that was called, along with the parameters that were called. So you can do things like this on Aranex to explore how other people are using the chain, and that's really useful. This is Modulus Cloud, which I would hope at least some of you are going to use. This is our infrastructure service for Tezos. When you sign up with your GitHub account, there's a free tier. You get access to a Tezos node, a high availability node. You get access to an indexer, the same indexer that powers the Galleon wallet, both of them, and Aranex, among other things. And you get this access for both testnets and mainnet, of course. Right. These are the wonderful things that we're working on for Tezos right now. And everything that they're built on, we also make available. So we have a project for the blockchain indexer, that's Kansei, that's open source, you can contribute. We would love your contributions. There's also Kansei.js, which is a library that we use to build UIs. So Galleon, Aranex, even Galleon Mobile, they inherit functionality for Tezos interactions from Kansei.js. So it's a very portable library. And we build things together. We frequently partner with people. Even if we don't necessarily form an official partnership, if you will, we try to help as much as possible. So there are various projects around the Tezos ecosystem that use our tools, and we help people as much as we can to get started and fix issues. And we are very responsive to user needs. So if, for example, Kansei.js is missing a function that you're dying to have, let me know and I will do my best to add it. So to that end, we're very excited to see you guys turn a pile of cryptographically enabled code into actual product demos. So let's talk about how to build on blockchains. Blockchains are adversarial environments. You should assume that people will attempt to break your code as much as possible. You should read about other people's successes, but importantly about other people's failures and how these failures were later mitigated. Ask for help. I think I've said that more than once, but not just us. There's a very active community of people on Reddit, on Twitter, that is ready to offer insight into how to make things work. Learn from other people. Again, what I mean is blockchains are intrinsically open source. You can look at the code for every smart contract that's deployed. Mickelson is not, I guess, the most user-friendly language to be reading, but very often the various popular projects on Tezos make their code available in higher level languages. So we're going to be talking today about SmartPy. There are a bunch of popular projects built using SmartPy, for example, and you can see their code. For that matter, Aranex as well can help you with some of this. You can see how people interact with smart contracts. You can see how these smart contracts fit into a blockchain-enabled product. So for example, Plenty, a DeFi platform, or Hicketnunk, the NFT platform, or Calamint, which is another NFT platform. So there are already existing projects for you guys to learn from. And because of that, you don't need to start from scratch. Concentrate on the interesting thing, that the value that your idea adds to the platform or the product that's exciting, like the core of the thing. Don't try to build absolutely everything about it. For example, you can use Modulus Cloud infrastructure. There is no need to even try running your own node, unless of course you want to build an infrastructure service, which I do not recommend. It sounds like fun. It's very little actual fun. Wish I would know more about this, but I would argue it's unfun. Do not build infrastructure services. If you need a component, if your system needs a token, for example, whether it's a fungible ERC20-like token or an NFT, there are already very competent examples that you can either use outright or you can extend for the functionality that you need. Yes, excellent. Finally, I can't stress this enough. And this, for that matter, is the reason why we use SmartPy. SmartPy is not just a syntax for developing smart contracts. It's also a simulation platform that allows you to test your contract before it's even deployed to testnet. You can run through all the workflows in your contract. You can run through all the conditional scenarios in your contract before anyone touches it on chain, even on testnet. And that's really critical. A couple of years ago, this is an example I like to think about. I was writing a really dumb sample game, probably for a workshop. And the idea was that users deposit XCZ balances, and there's some conditions on which they can win. And it turned out that there was an edge case where if you were at the bottom of the list, there was a path for you to claim the entire balance of the winnings, even though you lost effectively. So testing is really important. So all that advice, of course, is valid for any blockchain. But let's talk about Tezos specifically and how it's applicable here. Om said that a lot of you already have some experience with Tezos, and you had an introductory session prior to this, but let's cover that in a single slide. Tezos is proof of stake platform. It's been live for, I want to say 3 years now on mainnet, which is very interesting. Tezos is what Ethereum wants to be, and they keep delaying it. And in the meantime, we're live for 3 years. Not that, this is really a statement not about the fact that Tezos is an amazing, best platform, but the fact that the governance process, which Tezos has implemented, is crucial to the technical functionality of the chain. And I have a practical example for this. There was a recent upgrade called FlorenceNet that fundamentally changed how smart contracts interact with each other. It's a big deal. And this change, where inter-contract calls went from breadth first to depth first, meaning that instead of queuing up all of the calls that are made from one contract to other contracts calls internally are made immediately. So this is not how the original platform worked. This was changed through the governance process. A protocol upgrade was deployed to alter functionality. This is a very hard thing to do, but Tezos makes a regular show of it, and that's incredible. Also, smart contracts on Tezos have some guarantees around them. So they're strongly typed because Mickelson is strongly typed. They are potentially formally verifiable, again, because of the choice of languages involved in this platform. Finally, this is somewhat annoying, but there's continuation passing style, which makes things somewhat more difficult as far as writing contracts, but very doable nonetheless. Excellent. Let's talk about how to actually build smart contracts. And we'll do that with talking about how people interact with them. How might you call a smart contract? You might ping it. what does that mean? A ping is simply calling a contract just to register the fact on chain that some address has called a contract. Now, you might provide parameters with this. An example might be running a really cheap polling service. You can deploy a smart contract that has no actual functionality internally, but simply accepts a parameter. And then you can say on some social media service that I am running a poll. Please vote left or right against this smart contract. And internally, the contract does nothing. So people will invoke the contract, they say left, they say right. At some point when the voting period is over, you will simply use a block explorer, like RNX, for example, to count how many operations to this contract over the voting period in terms of time have contained parameter left and how many have contained the parameter right. And that's it. You have conducted a poll without actually making a complicated contract, without making the contract execution expensive, simply just invoking it, saying, hey, I'm Mike, I say left. That's it. You can invoke a contract. What I mean by that is you can provide parameters that will actually be fed into a function that will somehow change the state of the chain, meaning that I may transfer some token balance from myself to Ohm or from myself to Vishak, maybe to both. So I will invoke a token contract to send balances. Now, this is a function. It changes state. It takes parameters. It changes storage. Of course, it's recorded that you can view it on the block explorer and so on. You can also fund a contract. What I mean there is it's possible to invoke smart contracts without sending a balance in terms of X to Z to that contract. So you can call a contract to do a thing, and you don't have to give it any money to do it. The transaction fee goes to the bakers. That will include the transaction on chain, but the contract itself does not receive any funding. And finally, you can sequence calls. There are two ways to think about this. One, Tezos has this wonderful, incredible feature, which is that transaction groups, operation groups, I should say, execute atomically. What it means is that if I call a contract, for example, to stake USDTZ on Plenty, how would I do this in practical terms? I have to call USDTZ to approve a balance transfer from my account to the Plenty account. Then I have to call the Plenty contract, say, hey, go grab 10 USDTZ to stake. And then internally, Plenty is going to call the USDTZ token contract and say, hey, give me 10 of Mike's USDTZ. So there are two things at play here. We have two external operations, which I signed, and we have an internal operation from the Plenty contract to the USDTZ contract. So if for some reason the Plenty stake operation fails, the USDTZ approve operation that I signed first will also fail. And this is really, really useful for complex systems. All right. In the code itself, it's important to remember that technically smart contracts are immutable. Once you deploy the code, that's how the code is going to be. And if you didn't add a feature, that's it. You end up with what you deploy. Somewhat different later. Privileged access. What I mean here is Tezos, like many other chains, is a permissionless blockchain. Anyone can execute any function, which means that if your contract requires special access to some functionality, you have to explicitly implement it. So one example is an administrator account that can perform special operations on the contract that nobody else can. And this isn't necessarily difficult. You just have to have a function that says, is the caller of the contract the person, or the address rather, I recognize as the administrator? And you will simply store this admin address in storage of the contract. And this is, we're going to do this in the smart contract we'll be writing today. Another thing to remember is that smart contracts intrinsically are incapable of doing balance transfers. So unless you add a function for balance transfer, And any balance that that contract ends up with is immovable, short of a protocol upgrade somehow. So what I mean by that is if you deploy a contract and some user accidentally sends them, I don't know, 1 million XTZ, right? That 1 million XTZ will always be stuck in that contract. There's no way to recover it unless you have a function for that. Along similar lines to privileged access, you may want to restrict access to your smart contract for some reason. KYC, let's say, not a popular acronym around these parts, but perhaps you're running a smart contract for a club for people with whom you meet in person, and you would like to restrict access to this contract just to those people. So you can create a whitelist similar to this privileged access admin thing that only allows a certain collection of people to execute functions on this contract. Finally, state rescue. This is, in some sense, the betrayal of the smart contract paradigm, because what this means is you can execute arbitrary code against your contract that can change the state of the contract in undefined ways. So I said earlier that contracts have permanent deployment, and that's true. The code you deploy in the contract itself can never change. But what you can do is you can say, well, I have this special entry point. This is what functions are called in smart contracts on Tezos, entry points. I have this entry point that allows the administrator, let's say, to execute arbitrary code. Now, this could be useful, for example, in my earlier case where you want to refund a user who has accidentally sent funds to the smart contract. How would you do it if you didn't explicitly define a function for this? Well, you can have a state rescue function. The problem that I see here, for myself at least personally, is it's impossible to deterministically audit a contract that allows code execution like this, because it can allow an administrator, and this administrator, by the way, is an address on the chain. It doesn't necessarily mean that this address has any reputation or that there's a name of a person or a company associated with it. So it allows an administrator to execute code that says, well, I'm going to take all the tokens from all the users, for example, right? So not great, but also sometimes necessary. Other things to think about. Input validation. So calling contracts costs money, right? You submit a transaction fee that a baker takes, and the fee is proportional to the computational complexity of the contract. So when you're validating user input, you're spending money effectively to do that. What if there are cases where you have logic in the contract that would simply fail for invalid input? So if I send in invalid parameters, the contract will run and will fail to change state. So the error is guaranteed. Should I then force everyone who calls my contract to pay for the validation of the parameters that they know are correct in an effort to make it somewhat easier for other people to interact with it? I don't know if there's a right answer here necessarily, but this is another thing to think about. Storage is another. Storage is also a cost. Users will pay for storage they use in the contract. So if, for example, I'm authorizing Plenty to withdraw my USDTZ balance, what I'm doing is I'm creating a record in the map for the USDTZ contract saying Plenty, Mike, 10, right? So there's some bytes here, and these bytes need to be paid for. Obviously, in this case, this is required because that information is going to be used by a smart contract later. But in my first example of voting, there is no need for storage. That's another thing to consider. Fractions. So floating point numbers are presented on various computing systems differently, which is why blockchains, because they're cross-platform, meaning that you can run a Tezos node on an ARM chip, you can run it on an Intel chip, and so forth. Blockchains don't support natively floating point math. So what you end up with is large ints. you could have an int that's 36 digits, right? So I think the Calibri DAO contract token contract is 36 decimals. That's a lot of numbers. And this is something to think about, by the way, when you're writing UIs, especially in JavaScript, where they don't natively support numbers that size. And if you're doing math, you will end up with ridiculous results unless you're using a big number library or something along those lines. But the thing about fractions is that the USDTC token, for example, has 6 decimals. The Plenty token, I believe, has 8, but don't quote me. But my point is the number is different between different tokens. Finally, external state. There's this concept of oracles that some of you, I'm sure, are already aware of. There are some very useful oracles available on Tezos today, but you have to think about how you're going to be using Oracle data, because this is ultimately state you cannot observe directly. This is state that can change without notice and not be reflected in the Oracle. So when you're making considerations against external state, you have to think about safety of those decisions. So we touched this a second ago, loose immutability. It is possible not to just call a contract with arbitrary code. It is also possible to store this code in contract storage, which means that your code is effectively upgradable. This is somewhat more palatable, I would say, than allowing arbitrary code execution directly. Because at least if the code is in storage, you can review this code in Mickelson. You can get comfortable with it and still call the contract. It's not exactly the same as a full static audit, but at least you know what you're going to be calling. And of course, you can observe the contract for state changes. So you can see if the Lambda that was called transfer previously had this piece of logic and now it has a different piece of logic. You will see this on change. You will see this change. So that's another thing to think about. But anyway, let's actually write a contract. And today we're going to make a DAO. It's going to be really simple. But what's a DAO? It's a decentralized autonomous organization, I believe the acronym stands for. So we will distribute tokens to our DAO participants. These participants will be able to create and vote on proposals. And DAOs create an interesting collection of philosophical questions, right? In our case, you will require a stake to be able to propose. Why? Because blockchains are adversarial environments, people will look to abuse your contract. And one way to abuse it is the nothing at stake issue, where people can effectively spam your DAO with spurious proposals if it's cheap or free to do so. Now we are requiring users to hold a stake in the contract in order to submit proposals. There'll be other questions that we're simply going to gloss over. For example, what if a proposal fails? Or what if a proposal has low participation? Should this proposer be punished? Meaning that, was the proposal they submitted intentionally bad to just clog the process? So should we perhaps take some or all of the tokens they staked in order to be able to submit this proposal as a deterrent to bad actors? Vote thresholds. This is a problem that governments deal with, right? So how do you decide on what defines majority? Is it 50% plus one vote or something else? And we'll see code that does this. It's not particularly complicated, but philosophically, if you're deploying it now, this is what we need to contend with as well. But let's actually write the code in SmartPy. Excellent. Can you guys still see my screen?
Yes. Yes.
Excellent. And I'm assuming it's this beautiful SmartPy window. Excellent. So SmartPy, as the name suggests, is a Python-based toolkit. So if you're familiar with Python, this is largely going to be familiar to you already. There's some differences between Python and SmartPy syntax for reasons that are described in their very extensive documentation. I highly recommend you guys look at it. It's available in the help section up here. So contracts have parts to them. So first we're going to define this named DAO contract. It's going to inherit from the standard SmartPy contract class. Basically, here we're saying we'll name our contract named DAO. There's a required init function, and it takes at a minimum a self parameter, but we're also going to feed it two parameters, name and settings. Note, and this is kind of ironic actually, Michelson is, and smart contracts on Tezos are strongly typed. Python is not strongly typed. So SmartPy uses type inference to add this type safety to their contracts. So here, we're not explicitly defining name, but it will be inferred later. I'll show you how to be a string. Settings, again, we're not explicitly defining, but settings will be inferred. What else do we have? We have deposits, and it's a mutaz type of 0. So we're setting some defaults, basically. We're going to have a map of balances. So as I mentioned earlier, a DAO requires a token. So in this case, because we're doing a quick example, the token will be directly integrated into the DAO itself. So it's a map of address to an actual balance. TNAT, in this case, is a natural number type. We will allow people to vote. So we're going to record the voter address along with vote information, which is weight, meaning the size of their vote, which is directly proportional to their balance, token balance. Direction, in our case, it's just going to be +1 or -1, left or right, and level at which they voted. Those smart contracts are interesting in that they offer a lot of access to temporal data. So inside a smart contract, you know which level you're at, and you know the current time relative to the previous block. So this is really important, and it allows you to build, for example, financial products that are similar to real-world financial products, because again, you actually have time available to you. And level in this case is interesting because we're going to be basing our voting duration on the number of levels, meaning the number of blocks that have elapsed since the proposal was submitted. Okay, voters is a list of voter addresses. I'll explain why and when we get there. And proposal is just a definition of a proposal, which we have a proposer, the address that submitted this proposal, the new name for the DAO, which is a string, and an expiration, which is going to be calculated. Expiration in terms of block levels. Okay, so let's cover this in a little bit. Let's talk about claim. What claim does is it allows you to submit, or rather, it allows you to deposit some XTZ into the contract and get tokens for that deposit. So this is how we do validation. I say unless the amount being deposited is greater than 0, fail. Is this important? I don't know, it's hard to say. It obviously costs money to execute this line of code in the contract. But what's the implication of not having this line of code? Well, if someone sends in 0, we're going to increment the user deposits by 0. We will create a token amount. So we need to convert XTZ amount into a natural number. And as I said earlier, that smart contracts on Tezos are strongly typed. So the XTZ type, XTZ amount type is different from a number type. So we need to convert them. So this is what that does. And we're using the ediv function. Really, though, they have this thing that I made a note for you guys. There's a utils helper function to convert mutas into a natural number. And we're using that later. So then we'll increment user deposits by 0, issue 0 tokens, and record that this user, which is the sender, has 0 tokens. Does that matter? Not really. We're basically forcing the user who called the contract incorrectly to pay for an execution, which is ultimately useless. They would have called the contract, paid for storage, and all they did was nothing. They still can't vote. They can't submit proposals because the balance is 0. So checking that the submitted amount is 0 isn't really critical to the safety of this contract. So it's questionable whether it's necessary. Okay. Refund. That allows users to withdraw their XCZ balance and burn the tokens in the process. How do we do it? First, we check if they voted. If they voted, we remove them from the current vote tally and send them back to XCZ. We should also probably decrease the amount of user deposits. So let's do that. That would be nice. And then we send it to them. We send the XCZ amount that we calculated from their balance to the user. Another thing, by the way, that we might want to check here is whether or not this balance is 0, because it could be potentially 0, but we're not. Transfer, let's cover later. So now the DAO pieces, the actual proposing and the voting. Here, we would like to maintain some guarantees about participation. For example, does the sender of this operation have a balance in the first place? And if they don't, we should fail. Is there a balance above the threshold? What we're doing in this contract is we're going to require users to have at least 1 million tokens in order to submit a proposal. But if you remember above, we issue 1 token for 1 microtez, which means that any user that submits 1 XTZ will gain 1 million tokens. So for the purposes of this example, I think that's good enough. But at the same time, if I send in half a Tez, I will get 500,000 tokens. I will still be able to vote, but I will not be able to submit proposals. Okay. Another limitation of this contract is there can only be 1 proposal at a time. So we were talking about adversarial environments earlier. If submitting a proposal was free, or if it only cost the amount of transaction fees, people might spam the system, clogging it, therefore, because there can only be 1 active proposal. So that's why we require a stake. And finally, and this again is debatable whether it's necessary, but we're going to check if the proposed new name of the contract matches the existing name. And if it does, there's no need for this proposal because we already have this name. Now, I mentioned earlier that SmartPy is going to parse out the types for the data that it's using. So up here, actually proposal we define. Right, so we create a new proposal record. The name that was submitted by the user who submitted it, the level at which it was submitted, plus the proposal duration, which is a setting that we have. That's going to be the expiration of this proposal. Great. Now that we have a proposal, we can let people vote on it. Who can vote? Well, people who have a balance. When can they vote? They can vote if expiration is in the future relative to the current level. How do they vote? They can vote yes. And we don't define another option, but in the test, you'll see that it's actually nay is what they submit to vote the other way. There is no else if in SmartPy. So for example, if I wanted to do else if, I would do it like this. And that's an else if right there. Right, so when people submit votes, we convert their token balance to a weight that we are going to record in the votes map. We set the up or down direction and we record the level at which they vote. So we actually do this. Excellent. And lastly, we record their address in the list of voters. Why is that important? Tezos has several large storage structures available to you. One is called map, another one is called a big map. The difference between the two really is how they're actually recorded in physical storage. And it turns out that a big map, which is cheaper to use because when you change a big map, you're only touching a single record as opposed to the entire map. So when you deserialize the map, update a record and serialize it again, you're performing that operation on the entire map. In the case of the big map, you index to a particular location based on key and only modify or delete that key. So it's much, much cheaper, both in terms of storage and in terms of computational complexity. So token contracts, for example, use big maps to keep track of balances for their users. But what this means is that it's impossible to get a list of keys. So what we're going to do is we're going to externally record the keys that we know the map contains. But this also means that we have to maintain this list manually. So voters is a set. So we're guaranteed to have distinct addresses. So that's given to us for free by the platform. Excellent. So now people can vote. Finally, we want to be able to tally the votes. I decided that anyone should be able to tally the votes. So as long as the proposal period has ended, meaning that we're after expiration, we can count the votes. How do you do that? Because we're doing, rather, we have to have temporary variables to calculate the yay and nay votes. So we had something like variables over here. But internally, this line doesn't actually generate a variable. Internally, it's an alias. It basically says XTZ amount isn't this value, it's this code. So when SmartPy compiles this thing into a contract, this code, well, whatever code that function is made up of, is copied into the things that where we use it. Now, if we want to explicitly create a variable, we have to define it like this. So, yeah, tally, SP local, we give it a name, and we give it an initial value, in this case 0. So that's my comment here. Other assignments are just aliases. This is a variable. So here, what we can do is we can do this increment. So as I said earlier, big maps don't expose their keys. So what we're going to do is iterate over the voter set. Then we're going to feed this voter set into the votes map to get the vote instruction. And if the vote occurred after expiration, we ignore it. This is just additional safety. And then if the direction was +1, it's a yay vote. If a transaction, I'm sorry, if the direction was less than 0, it's a nay vote. And finally, simple majority, if the number of yay votes is greater than the number of nay votes, we adopt the new name of the DAO, and we're done. We clear the votes, we clear the voters, we reset the proposal. And that's it. And this is a DAO. There are a few things that we glossed over, and then we could go back to them. the default entry point is special. The default entry point is necessary if you expect your contract to receive balances. Now, this is useful for things like delegation. So for example, if for some reason your contract actually accepts XC balances, the contract should be delegatable. On the other hand, if you do not expect to be receiving balances and you're not going to delegate the contract, you should include refund logic here. And the refund logic would be something really simple. Something like that. And that's it. So what we're doing is as soon as the user sends us a balance, we just send it back to them. It'll still cost them money, but at least they're not going to accidentally lock significant balances in the contract. Excellent. If we are going to maintain balances, then we need two other things. We need a set delegate function because, of course, on Tezos, you want to participate in the blockchain governance process. And here, we're going to check if the user submitting this request is actually an administrator, because this is a privileged function, right? Your contract may potentially contain a large balance, which could potentially have significant weight on a proposal vote. And I don't mean, of course, this DAO proposal vote, I mean the Tezos proposal vote. So you may want to delegate to a specific baker of your preference. So perhaps since this is DAO, maybe we will have a vote on which baker to delegate to. But the point is that you have to have an explicit function to set a delegate. And finally, withdraw. So the contract is going to accrue delegation rewards, and the system may be designed in such a way where you as the admin claim these rewards for yourself. So then you should be able to transfer this balance to yourself. So again, we confirm that this privileged operation is being executed by someone who we expect. And then we send them the user balance, I'm sorry, the total balance minus the user deposits, because of course we're not stealing anyone's money. Super simple DAO. Lots of things are not here, and we'll cover how this can be improved. But one glaring example here is you cannot change the administrator. So it would absolutely make sense to have a function that allows you to switch the admin. I think we have 2 minutes that we can write that function right now. We, of course, want to confirm that we're currently the admin. And then, really easy. And we're done. This is how you switch administrator. So let's see. I believe it was actually the settings structure that we're not explicitly typing. And I said that it's going to be inferred. How does it get inferred? Through the testing mechanism. So the way I introduced SmartPy is that it's a simulation platform. So what we can do is run through all these scenarios before we deploy the contract. What we actually want is this. Not sender. That would set the admin to the same admin. Right. So how do you set up tests? Pretty simple. And you can get these pretty printouts of everything that's changing. And you can get a table of contents that points towards your different test scenarios and so on. Very nice. So we need to initialize the contract. We do that by creating a settings structure. So what SmartPy is going to do is it'll see that settings that we defined upstairs is actually a tuple containing 3 elements: admin address, duration, which is the expiration, the valid proposal duration, the minimum proposal stake, which is 1 million. And then when we say create a new instance for testing, we say name DAO and settings. And that's how SmartPy knows that this is a string and this is a tuple containing the specific elements that we defined down here. So it's actually necessary to create tests. It's not optional, although there is a way, of course, to write these contracts in such a way that they're fully defined types everywhere, but tests good. Right, so we created an instance of the DAO, I'm sorry, we are adding it to our simulation scenario. We created a bunch of test addresses. So these are the users who are going to be interacting with our contract. And then let's have them do stuff, right? So first, we issue a bunch of tokens to our participants. So Alice, Bob, Clara, and David all get tokens. Then Alice proposes a new name. We send in the name parameter, and it's going to be new name. The sender is Alice, and the level is 1. So this is arbitrary, right? Like you can set this to any positive number. In this case, these things are in sequence because we're interested in the sequence and we have certain thresholds to meet, like the 32 level duration for the completion of the vote, for example. But these are sequences. You can also use a timestamp instead of level. But let's look at why this is called name. And the reason it's called name is because here we're expecting name. So what this does in Nicholson, if you've looked at that already, it creates annotations. And annotations are super nice if you're looking at the code of the contract as a developer, a third-party developer. Like someone wants to use your contract, for them to figure out how to do it will be a lot easier if you have annotations that describe, at least to some extent, what this thing is doing. So Alice will propose a new name. Then Bob is going to fail to propose because we only support one at a time. So what we're saying is this is a failed test and we expect this failure. It's important. It's really important to test not only the success scenarios, but also the failure scenarios. So that's one such example. Then a bunch of people are going to vote. They will vote for and against. And then one of the users is going to tally the votes at level 34. Why is it level 34? Well, let's go look. So we accumulate tokens. And as you can see, state changes across execution. So first we have, I believe, Alice claiming 4 million tokens. So the balances map is updated to 4 million for Alice. Then Bob claims 5 million tokens. So we added another record to our map. This keeps going until Alice proposes a new name. So we see that the propose entry point was called. The name parameter is new name, and so on. So now we have a proposal that's live. It expires at level 33. It's new name. It was submitted by Alice. And this is our admin structure. Setting structure. Excellent. We have no votes yet. Robert cannot submit a proposal because one is already active. And see here, you have the error message. This error message will also be included in the contract itself. So when you deploy this thing on mainnet or on any net really, this error message will actually appear in the logs. Of course, this string adds to the size of the contract. So you again might want to think about how you write down the errors. So for example, one other pattern people use is they create an error map, which is an index of number to error message, and this is going to be called error 1. And then somewhere you provide documentation on the internet saying, oh, if you called this contract and the error you got was 1, well, this is what it means. Fine. Now we're going to vote. So Claire's going to vote, and what it's going to do is it'll add her address to the voter set, and it will add the vote to the votes map as well. So we have the weight of 5 million tokens at level 3, direction yes. We'll do more votes. So Robert's going to vote against. So we have a -1 direction for his vote. And then we tally. And what does Tally do? Tally will adopt the proposal, as we did. And the reason we adopted the proposal is because previously we saw that there are 10 million tokens in favor, 5 million against. So the proposal is adopted. Excellent. Now Bob is going to propose a different name. Same process. We'll go into some votes, but then this scenario is slightly different. Originally, Alice only has 4 million tokens, so she will be defeated in this case. But we would like to test the scenario in the DAO where the proposal fails. So what Alice is going to do is she will increase her stake. So you see the balance of the contract changes. Alice's balance has changed, but we're not automatically updating the vote balance. And this is a design choice. You can absolutely do this in a single transaction, where if a user increases or decreases their stake in the contract, it automatically updates their live vote, should they have one. So then Alice is going to update her vote to include the new stake. And finally, when David tallies the vote, it will turn out that the proposal is defeated and no change is made. So this is a really quick example of a DAO. Lots of ways in which it can be improved. So let's talk about that for a minute. You want your contracts to be modular. This is ultimately still software. So I mentioned earlier that this DAO integrates the token functionality internally. That's bad design. You should use a separate token contract, and these are readily available even in SmartPy. In the same UI, they have sample contracts you can just pull in and deploy. Multi-sig admin. This is both a safety feature from the perspective of the administrator of the contract and also a confidence feature from the perspective of users, where it says, well, this isn't on a random whim of a single person. This is actually some sort of a group that decides how these things should proceed. We should most certainly support multiple proposals because generally speaking, votes happen on multiple choices, not a single one. And Lambda proposals. This is a really simple, silly DAO, demonstrate how DAOs work, but it's not useful. What we want to do is to be able to have this DAO perform operations. For example, I mentioned earlier, delegation. So if we supported Lambda proposals, what you could do is you could submit a proposal to change the delegate of the contract, that 25 XCZ that this contract contained, to point to somebody else. That would be a very useful feature as well. It would be a feature that would make this a real DAO, really. Now, security. I've looked at lots of, well, we really as a team have looked at a bunch of projects that people submit for events like this. And very frequently, they include security assumptions that they say, oh, well, if this happens, we have this vulnerability, but we'll fix it later. Don't do that. It occasionally becomes impossible to fix these vulnerabilities because of the assumptions that you make. Not because you can't upgrade the contract necessarily, but because the logic is simply not sound. So when you guys are submitting your projects, please think about how this actually gets used on a real chain with bad actors around every corner. Awesome. So this is us. I work at Cryptonomic. We're all over the internet, as you can see. I will make these materials available in the next couple of days. In the meantime, if you want to take a look at some of the other materials that we have available already, there is this very detailed example on how to use oracles, incidentally, from last year. So there's that. This is me on Twitter. So that's what I have. If you guys have questions, I have some time to stick around and answer them. Thank you very much.
Thanks, Mike. Thanks for that overview. yeah, happy to, if anybody has some quick questions, happy to take them over. Dave has a question.
Yeah, hi Mike, great talk, enjoyed it. I had a question regarding the admins that govern the contract. So the question that I had was, why do we require an admin? Can we take executive decisions based on the stakes that people are, or rather addresses are holding in the contract? Is that a good idea, or having exclusive admin access is necessary for some reason that I don't see?
No, an admin isn't necessary in all cases. No. In the example here, the admin the admin account is necessary for setting the delegate, setting the baker to whom this contract is delegated. You want this to be a privileged operation, and the reason is, like I said earlier, otherwise people will randomly set the delegate perhaps to someone whom you do not want to be set to. Or a baker themselves may decide that they would like to have extra voting power in this current Tezos proposal and set the baker to themselves. So this should be a privileged operation. Another privileged operation would be the withdrawal of funds. You certainly don't want random people to do it, but not every single contract is going to have this feature. Also, if this contract had a manual mint function, which it does not, it mints automatically based on the amount of XTZ that the user deposits. The mint operation and the burn operation are also privileged. You don't want random people burning other people's balances, of course. But no, it's not necessary in all cases.
Got it. Thanks so much.
Actually, I also had a question. I wanted to ask, what is the difference between using levels and using time as the expiration for the contract and the proposal?
Levels is a new feature for Tezos. I like the idea. For things that are tied primarily to the chain, I think level is a better measure of time because it's chain native. Regular timestamp time is more of a human space construct than a blockchain space construct. So if this was, for example, a savings account contract, I might want to use timestamp instead to denote interest payment periods instead of levels, because people, generally speaking, when they approach a bank, they think in terms of time. But in this case, I'm just using level. You can use either.
Hi, I had a question that in case of tie of votes, what decision would be taken? Like,
well, this is what I mean by philosophical questions to address, right? Here we require strictly larger amount, but you can decide. You can decide that maybe, I mean, this is just a sample, right? So perhaps you feel strongly that the majority should be significant. So you want 60% majority before you adopt a proposal. It's up to you.
okay.
Could you again show the QR code for the extra material you talked about?
Yeah, the QR code for the Oracle example?
Yeah. Thank you.
But I will clean up these materials into publishable format and make them available as well. All right, well, you guys know how to find me. Tezos India guys can put us in touch as well if needed. So thank you very much for listening.
Thanks, Mike. Thanks for that. And yeah, hope to see you around. We have a Slack set up for this. Hope to see you around there when you can. And yeah, so for the rest of you, we have us your Slack setup. You can join in there. You can introduce yourself. We have a water cooler channel there. And then, yeah, we'll have more of these sessions in the coming days. We'll be sending out the links to you soon. And yeah, that's how this week will go. And I already gave you the overview earlier. So yeah, thanks everyone for joining in. See you all on Slack.
Bye, guys. Good luck and thank you.
Bye-bye.
Good night.
Good night.
Bye, guys.
Bye, guys.